Hi guys, welcome back to Nunley Math. I'm Aaron Nunley. Thank you for joining me here today for the second part of our lesson on angles and angle relationships. You can see I've already gone through and uploaded the first video up to YouTube. I've included a QR code link as well as two different ways that you can access that channel. If you've not watched those already, I'm going to recommend that you watch those before viewing this because I'm going to dive right into some information that is dependent on the things that we discussed in that previous video. So make sure you're cool on those things before watching this one, because today we're going to talk about more complex angle relationships. Here are some things that we know. We know that if two lines are parallel and are crossed by a transversal, several things are true. Now, this begs the question, what is a transversal? A transversal is a line in geometry that crosses two or more other lines. So you'll notice that I have a line here. I have a second line that is parallel to it, meaning if I extended these two lines on forever and ever, they would never cross. And then I have this line right here. I'm going to call this line AU. Line AU crosses both the other two lines. You can see it crosses line DG here at point O, and it crosses line BT at point I. Because this crosses at least two lines, we would say that is a transversal. And notice that I'm going to be talking for just a second about this top intersection. You can see I've already highlighted it in yellow because that's what we talked about in the previous video. We said if I have two lines that cross one another, they form a recognizable and repeatable pattern. We know that if this is 117, this little angle next to it has to be supplementary, meaning it has to add up to 180, which means it must be a 63. We also happen to know that if this is a 117, the angle directly across from it is going to be congruent. It's also going to be a 117. And we know that if this acute angle is 63, the angle directly across from it is going to be 63 as well. This is what we discussed in the previous video. How when two lines intersect, there are very predictable angle relationships, things that occur every single time. But here's the cool part about this example. If I know that line DG and line BT are parallel to one another, if this horizontal line and this horizontal line are parallel, check this out. Let me do that again. That was fun. This intersection and this intersection are going to create the exact same angles, because if these lines are parallel, the transversal should cross them in exactly the same way. So if these lines are parallel, there are lots of other things that I can tell. For example, this angle right here. This is also going to be 117 because this was 117. Let me do that again. Everything that's up here at this top intersection is going to duplicate down here. So this is going to be a 117. This, just like the top left was a 63, this is a 63. Just like the bottom left was a 117, the bottom left is a 117. And just like the bottom right was 63, the bottom right is still a 63. I think that's pretty cool. But it's only true if the two lines are parallel. If we know any one of these 8 angles, we can figure out the other 7, but only if the lines are parallel. I think that's pretty cool. Here's what happens if the lines are not parallel. You can see I still have the 117, which means this is still an intersection of two lines. This is still a 63, this is still a 117, and this one over here is still a 63. But when I try to move them down, notice that the transversal crosses in a different way. This line does not measure up with this angle. This 117 is actually a larger angle than the one we're looking at right here. So what's the measure of this? I don't know. I don't know. I don't know. I don't know. If I know the lines are parallel, I can figure out all 8 when I'm given 1. But If the lines are not parallel, I'm limited to those angles that are immediately in the same intersection. See how that works? So let's try this. Suppose I have these two lines and I have a transversal AU that crosses both of those. Can you figure out all 8? If I tell you they are parallel, can you figure out all 8? Well, hopefully you realize that this must be supplementary because 139 and 41 have to equal 180. Once I know this, I can figure out all the others. All my acute angles are going to be 41, and all my obtuse angles are going to be 139. I'm going to take this entire pattern, I'm going to duplicate it down here below. 41, 139, 41, and 139. Again, it's only true if the lines are parallel. How about this? If those lines are parallel and I tell you this one's a 15, can you figure out the others? Again, I'm going to recommend you pause the video, try this on your own. If you are unable to, you'll want to watch me in just a second. If you were able to, you can skim to the end and see if your answer matches mine. Notice these are side by side and share a common side. They are adjacent, so they have to add up to be 180. That makes this a 15 and a 165. Everything I see over here, I'm going to duplicate down here only if the lines are parallel. So I put another example up here. Now notice this time I've already filled in all the angle degree measurements because I want to make sure we recognize a couple things. First of all, we've talked about the fact that this whole pattern gets duplicated down here at the bottom. We should be pretty good at that at this point. But notice something else. If I were to get rid of all the green acute angles, do you notice anything about all the obtuse angles? Well, of course, they are all the same measure. They're all congruent. I could come over here and do the exact same thing and get rid of all the obtuse angles. Notice that all the acute angles are all the same. They are all congruent. In fact, if we know any one of these acute angles, we can know all the other acute angles because they're going to be the same measure. If we know all the obtuse angles or any of the obtuse angles, we can figure out all the others because we know they're all going to have the same measure. And if I know any one of these obtuse angles, I know that any of the acute angles would be supplementary to it. You see those relationships? Very, very important that we recognize those. All the obtuse are going to be the same, all the acute are going to be the same, and any of the obtuse matched with any of the acute is going to have to add up to be 180 degrees. Now, we have different names for talking about these angles that are going to help us describe them when different combinations are given to us. For example, we use the term corresponding angles to refer to angles that occupy the same position relative to their vertexes, or they match up. So for example, if I were to take this angle in the top left-hand corner and this angle in the top left-hand corner, notice they're both in the top left, they're both acute, meaning if the lines are parallel, they're going to be congruent. Notice this top right and this top right are going to be congruent. Bottom left, bottom left, bottom right, bottom right. If I were to pick any pair of these corresponding angles, I need to realize that they are always going to be the same measure. They're always going to be congruent. If the corresponding angles are congruent, that is an indication for us that our lines are parallel. Likewise, if our lines are parallel, then we know the corresponding angles are going to be congruent. This is one of the different descriptions we're going to have. When we talk about interior angles are those angles that are between the parallel lines, and exterior angles are those angles that are outside the parallel lines. So if I were to give you alternate interior angles, I would be describing angles that look like this. Notice the interior angles are between the parallel lines, and they're called alternate interior because they're on different sides of the transversal. Alternate interior angles, you'll notice obtuse, obtuse. If the lines are parallel, we know these are going to be congruent. Likewise, These are also alternate interior angles. Notice acute and acute. Alternate interior angles will be congruent if the lines are parallel. Likewise, if the lines are parallel, we can prove that those are going to be congruent. Alternate interior angles. Notice alternate exterior angles are outside the parallel lines and on opposite sides of the transversal. They are outside the parallel lines, opposite sides of the transversal. Notice it's acute and it's acute, which means if the lines are parallel, then they are going to be congruent. Also notice that if we know they are congruent, we can prove the lines are parallel. It works both ways. These are also alternate exterior. Notice obtuse, obtuse. Those are going to be congruent. Alternate exterior. These are corresponding interior angles. Corresponding interior. Notice that they are between the parallel lines. That makes them interior. Notice they are both on the same side of the transversal. They're both on the left. This is obtuse. This is acute. If the lines are parallel, these two must add up to 180 degrees. They must be supplementary. Likewise, these are corresponding interior. You have an acute, you have an obtuse. Together they must be supplementary if the lines are parallel. Those are corresponding interior. These are corresponding exterior. Notice they are outside the parallel lines. They are on the same side of the transversal. Notice this is acute and obtuse. These will be supplementary if the lines are parallel. Likewise, these are corresponding exterior, outside the parallel lines, same side of the transversal. Obtuse, acute, they are going to be supplementary when the lines are parallel. Now, I know that's a lot of terms, but here's what that's going to look like for you in class. If I were to say, are these lines parallel and how do you know? I'm going to look at these and I'm going to answer this in 3 different pieces. Number 1, I'm going to say yes or no, they are or are not parallel. Number 2, I'm going to give the description of the angle's positions. Notice these are both on the outside of the parallel lines. Notice that they are on different sides of the transversal. These are alternate exterior. And since they're both obtuse, I know that if the lines are parallel, they should be congruent. So the answer to this would be yes, we know the lines are parallel because the alternate exterior angles are congruent. Now, this is a very long answer, but notice I have to include all 3 parts. I say yes or no, that's my answer. This description right here tells the reader or the grader or whoever's looking at our work what angles they need to be looking at, and this tells you what they're looking for as proof that they are parallel. Can you do this one on your own? I am going to recommend you pause the video and try it by yourself before listening to me do it. You might need to refer back to the definitions we had before. I'm looking at these. These are on the inside of the parallel lines. They are on different sides of the transversal. These are alternate interior. Notice it's acute and acute. These should be congruent if the lines are parallel. So I would say, no, these are not parallel because the alternate interior angles are not congruent. Got the idea? I'm just going to do a couple more of these and we're going to call it a day. Can you do this one? Again, I would recommend pausing the video, trying it on your own, and then watching me do it. I look at these. I can see they are between the parallel lines. They're on the same side of the transversal. These are going to be corresponding interior. If the lines are parallel, this is obtuse and this is acute, they should be supplementary or 180. 123 plus 57 is 180, so I would say, yes, these lines are parallel because the corresponding interior angles are supplementary. How about that one? Again, pause the video, try it on your own, see if you can get all 3 parts of your description. You got it? When I look at these, I can see that this is in the top right, This is in the top right. Those are corresponding angles. Notice it's acute and it's acute. If the lines are parallel, then that means these should be congruent or the same size. They are. These lines are parallel. The corresponding angles are congruent. I got 2 more of these just to get you some practice. Here again, pause the video, try it on your own. Notice I've turned it sideways this time. It doesn't change anything. These are both outside the parallel lines. They are on the same side of the transversal, so these are corresponding exterior. It's obtuse and it's acute, meaning these should be supplementary. But 110 and 60 are not supplementary. That is 170, not 80. So no, these lines are not parallel because the corresponding exterior angles are not supplementary. Last one. Again, pause the video, try this on your own, then restart the video. I'm going to do this one a little faster. These are not parallel because the alternate interior angles are not congruent. I knew they had to be congruent because they are both acute angles, and I know all the acute angles in these parallel, if these were parallel lines, all the acute angles would be the same. There again, it's a lot of definitions very, very quickly. If you did not take some time and write those down, I am going to recommend that you go back and write down those definitions with at least one example for each one so you will remember those. This does take some practice to get good at, but make sure when you're answering, you're giving all 3 parts. As always, I do appreciate you taking the time to watch this video. If you wouldn't mind, give us a big old thumbs up. Make sure you ring that bell to turn on your notifications so you'll receive all the new material coming from us here at Nunley Math. As always, I wish you the very best. Take care of yourselves. Bye-bye.